All right, well, welcome. We're going to work on probabilities of compound events in Khan Academy. And so this is one of the times that we have to do. Compound events are more than one probability events happening. So that could mean independent or dependent events. And so for most of y'all here, you've already had science, so you already know that independent variables and dependent variables. But most importantly, you have been telling your parents for quite a while that you want to be independent. You want your own cell phone. You can't wait to start driving, right? So you can do whatever you want. A lot of y'all do not want to be dependent. You don't want to have to rely on your parents or somebody else. You want to be independent. So you already kind of thought about this. But when we talk about independent probability, the easiest way I think of right now is flipping a coin. And so I brought this back from Switzerland by francs, but whatever. I really like the coin. It's a great flipping coin. But, when we're thinking about theoretical probability, what we think will happen, we're sitting here, we're going to flip this coin. All right, so what are the possible outcomes? You have that guy right there. You got heads, or you have tails. Right? There's only two possible outcomes, but you can't get both outcomes at the same time. You can only get one out of the two, so that means you have a 1 out of 2 probability. So let's say, what are the odds that I flip a coin and it lands on tails? That's 50%. Now, what are the odds I flip it twice and it lands on tails? Well, the first odds were 1 out of 2, correct? So let's go ahead and flip it. Got tails. All right, might be a weighted coin. All right, so what's my odds of landing on tails a second time? And this is where you have to start kind of thinking about it, dividing it out. Did me landing on tails just now, did that affect the odds of landing on tails again? Is it like I'm more likely to land on tails? No. The odds are the same, right? Because it's still 1 out of 2, 50-50. So we're sitting here, we're going to drop things everywhere. We're going to sit here, it's going to be 1 over 2, 50-50 times 1 over 2, which should be 1 over 4. I have a 25% chance of flipping tails 2 times in a row. Let's see if I'm lucky. Landed on tails again. I guess it might be a little weighted. But so I have a 25% chance of landing on tails. Those are 2 independent events. Now, dependent would be kind of like if you're doing a pickup basketball game and you have your buddies out there on the court and you got 2 captains, right? So the first captain picks. Imagine there's 10 people on the court. How many people does he have to pick from? 10. All right, what are the odds if you're just randomly picking one person, right? You have a 1 out of 10 chance at picking somebody. Now, if I'm trying to get picked, I got a 1 out of 10 chance. Now, the moment that first guy gets picked and the second captain gets to pick, how many people are on the court? There's only 9. So you got a 1 out of 9 chance, and it goes back, and every time you pick somebody, it takes somebody away from your outcomes, right? Because if I pick somebody, they can't be picked again. And so when we're thinking about stuff like this, you're looking at dependent events. It's where the probability affects the probability of another event. One event affects the other. And so you have to think about that a certain way. All right, so we are back here. Had a little technical difficulty, so camera's gone, but let's keep working. All right, so the first problem we're going to run into is Justin lives in St. Paul and goes to school in Minneapolis. In the morning, he has 3 transportation options: the bus, the cab, or the train to school. In the evening, he has the same 3 choices for his trip home. So if Justin randomly chooses his ride in the morning and in the evening, what is probability that he'll use both the bus and the train? So on this, the easiest thing to do is to make a table, and I already made that here. All right, so we have, let me get the little cursor here. We have, it's a 3 by 3. So in this column here, we have bus, cab, train. In this row, we have bus, cab, train. And you see that says evening up here. So in the evening, he has these 3 choices, and in the morning, he has these 3 choices. And so it takes a little while to do this, so I went ahead and made it. But it's really, in this column, he could pick the bus in the evening or the bus in the morning. He could take the cab in the evening, or cab in the morning, or the bus in the evening. He could take the train in the morning, or the bus in the evening. And in this column, he could take the bus in the morning, or the cab in the evening. You can take the cab. You can see how this is going. So let's look at our question again. It says that if he randomly picks, what's the probability that he'll use both the bus and the train? And so we're just going to look at one of these boxes that has the bus and the train, and we have one right here. And looking again, and there it is. Now, if I read the question correctly, these should be your 2 answers. So how many outcomes does he have, whether he rides the bus or the train? And so we have 2 outcomes. Let me go ahead and change this over. Now, how many total outcomes are on this board? Where we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So it should be a 2 out of 9 chance that he'll take the bus and the train. 2/9. Let's take a look here. All right, we got it. Great job. All right, we're on to the next question here, and it says that you're at a clothing store that dyes your clothes while you wait. You get to pick from 4 pieces of clothing: shirt, pants, socks, or hat, in 3 colors: purple, blue, or orange. What is, if you randomly pick the piece of clothing and the color, what is the probability that you will end up with an orange hat? Now, this is pretty strange. I've never been to a clothing store that will just dye your clothes while you wait, and then you just randomly pick what clothes you want to have dyed. That's kind of strange, but you know, it's an interesting problem. Now, just like the previous problem, we had to come up with a table, and so I went ahead and created that. And so right here we have the items of clothing. We have the shirt, the pants, the socks, and the hat. And then we have our options with the color: purple, blue, orange are the 3 colors here. And so the first thing is, you know, randomly you have to pick an item, right? And then you would get, randomly you would pick a color to dye it. So the question, and here we got all the options. So I could get a shirt that's purple, I could get a shirt that's blue, I could get a shirt that's orange, I get pants that are purple, pants that are blue, pants that are orange. And so I'm just looking at, you know, where they intersect here. Purple and socks, blue and socks, and that's all I'm looking at. It's just a great way to see all of your combinations. Now it says, if you randomly pick a piece of clothing and color, what's probability that you end up with an orange hat? So we can go here, orange. We're looking for orange hat. So we have orange shirt, orange pants, orange socks, orange. Yeah, no, I can't say orange very well. Orange hat. And so there's really only one combination here that says a hat that is orange. And you can double check me there. So we have 1 out of, well, how many total here? Now, a quick way would have been to multiply 4 times 3 would give us 12, or you can count up all these blocks, but you really only have a 1 out of a 12 chance of randomly selecting that. So let's double check here. Put that in, and boom, we got it. All right, we got 2 more. All right. All right, we're back on our third one, and it says Elizabeth lives in San Francisco and works in Mountain View. In the morning, she has 3 transportation options. She can take the bus, the cab, or a train to work. And in the evening, she has the same 3 choices for her trip home. If Elizabeth randomly chooses her ride in the morning and in the evening, what is the probability that she will use a cab exactly 1 time? So this is kind of cool. It's like that first problem we already did. And so I already have it written up here. And that's a good reason why you shouldn't always throw away your work, because it could come back to help you later. So let's see what the question was. It says, what's the probability that she'll use a cab exactly 1 time? So I don't care if it's in the morning or in the evening, but I want to see where it says cab just once. So let me get a highlighter here, and where it says cab just once. So I have 1 right here that says cab just once. Right here, cab just once. Can't use this because it's 2 cabs. Cab just once here. Cab just once here. And you kind of see a pattern too. Look, it's like a little plus sign there. So we have 4, and so there's 4 times that you use a cab just once. And how many total were here? Well, that's 9. So 4 out of 9. And again, that's great because we already did the work setting this up. And let's see if we got the right answer here. There we go. Let's move on to the next one. All right, we're on the final problem here. It says, if you roll 2 fair-sided six-sided dice, what is the probability that the dice show the same number? All right, again, we're going to make another table on this. And remember, dice are just like throwing any sort of board game you've had. You roll to figure out how far you go. It's like Monopoly. But we have 2 of them. And so you can roll, you're going to throw 1 at a time. So the first one, and here is our table here. So our first roll can be this column right here, and our second roll is right here. So you could get a possibility of a 1, a 2, a 3, a 4, 5, or 6. You can get a possibility of a 1, a 2, a 3, a 4, or 5, or 6, and this is where they meet up at. So I could get a 1 and a 1. I could get a 1 and a 2. I could get a 1 and a 3, 1 and a 4, 1 and a 5. And you kind of see how this goes. I could have rolled a 2 and then a 1, a 2, then a 2, then a 2, then a 3. And I understand it takes a little while to set up these tables, but once you do, it makes it a lot easier to understand what your combinations are. And, you know, understand that there is faster ways to do this, but that's something that we have to understand a little bit later. So let's go back to our question. What is probability that the dice show the same number? So here's the cool thing. Now that we can visually see this, let's just go ahead and see when there are the same number. So I see a 1 and a 1, right? That's the same number, right? 2 and a 2, same number. 3 and a 3, the same number. 4 and a 4, the same number. 5 and a 5, and a 6 and a 6. And you can go and double check and look all the way around here and see if we missed something somewhere. But you see a pattern? It's diagonal, straight across. Alright, so if you do any sort of crosswords, you probably already saw that pretty quickly. But how many total combinations? And each one of these are a combination, right? So we have 1, 2, 3, 4, 5, 6. There's 6 combinations. And how many total combinations are there? Well, one quick way is 6 times 6 is 36, or you can count every little block here, and you're going to get 36. So let's go ahead and plug that one in there. Oh, see if we got it. All right, good job. So main thing with this is, like we were doing here, take your time to make your tables. It'll make things a lot easier for you to understand. Also, you might want to pause the video so that you can look exactly how I set these up, so you can copy them the way you need to. And obviously email me. We can set up some meetings, things like that. But this is here to help you, and let me know if you have any questions. Thank you.